So our question is asking us to find the probability of a mental birth impairment for the child of a randomly selected male and female parented offspring. So first, let's find the probabilities of the smoking versus non-smoking parents. We know 100% is 1 and 10% is 0.1. So if 10% of the males of a population smoke, write 0.1 here. 10% of the females of the same population smoke, 0.1 here. How do we find the non-smokers? Well, that's just what's left. So we're going to do 1 minus 0.1, which is the same for both, and we get 0.9. Next, we'll identify the probabilities of mental birth impairments for each given situation. So let's refer to the question. If the probability of a mental birth impairment is 0.0 for neither parent smoking, 0.2 for one parent smoking only, and 0.6 for both parents smoking, we can write down that the probability of an impairment given that both smoke is 0.6. Probability of an impairment given that only the male smokes, 0.2, and another 0.2, and 0.0 according to the question. So recall that probability of and or are will have different operations. The probability of A or B occurring is probability A plus probability of B. This is only if A and B are mutually exclusive. So the probability of P and B would be multiplication. Probability of A times probability of B. So this would give you the probability that both events occur. Next, find the probability of each kind of pairing. So we're going to use their chart over here and just plug it in to find the probabilities. So probability of smoking males and smoking females are probability of smoking male, which is 0.1, smoking female, 0.1, and then we get 0.01. So we're done with that. The next one, probability of a smoking male times the probability of a smoking female, non-smoking female, we'll have 0.1 times, so the non-smoking female is now 0.9, and that will give us 0.09. So you can find the next two parts using the same chart. Finally, we'll find the total probability of mental birth impairments. So to find the probability of a smoking male and smoking female and impairment based on that, or as I wrote, probability of smoking male and smoking female times the probability of impairment given that there's a smoking male and smoking female. It's a lot, but that would be the notation. So we know smoking male and smoking females give you 0.01 probability. We're going to multiply that by the impairment given that both smoke, which is 0.6. So to multiply, we get 0.006. Okay, and you'll do the same for the next 0.09 for the smoking male and non-smoking female times the impairment given that situation, 0.2. That will give you 0.018. Okay, and then you can use your information from before to find the next two parts. And then when you're done, just add it all up. to find the probability of impairment for the entire population of random subjects.